record the session. All right, we should be good to go. All right, the first question, are they asking for the length of CE?
Yep.
No, they're saying find AB. They've given us the length of CE, just having a hard time reading it. What does it say? 5x plus 7? What's the length of CE? I can't read it.
5x minus 7.
Okay, so CE is 5x minus 7. What is AB relative to CE? What's the length of it?
I don't know.
It's twice, always. In other words,
Is it double?
it's double. So CE is a mid-segment line because it bisects BD and it also bisects AD. That's what makes it a mid-segment line, and mid-segment lines are always half of the base that they are parallel to.
Yep.
So AB would have to be 10x minus 14.
No, it's 8x. Oh, never mind.
It's twice whatever CE is. Okay. Number 2. Again, FC is a mid-segment line.
Don't we have to solve for x? And then find AB?
Do they give us any numbers? Did they give us a number on AB?
They didn't give us a number, but it's an equation.
Well, that doesn't mean we can solve for it. In other words, what we have is the length of AB is 10x minus 14. There's no way to solve that. Not without a number on AB. What does it say?
Well, we have...
What does it say right there? I can't read.
We have 8x minus 6. We have 8x minus 6.
Oh, that's what that says?
Yes.
Oh, okay. Well, then I can substitute that for AB. I couldn't read it. I didn't realize there was anything over there. Hold on. So that is 8x minus 6.
Yep.
Okay. And we know it's twice CE. So we know that 8x minus 6 has to equal 10x minus 14.
Yep.
Solve that for x, you get x equal 4.
Yep.
All right. Number 2.
And then plug that in.
Yeah, you're right, because they say find AB, and so AB is 8x minus 6, so it's 32 minus 6, 26. That's the length of AB,
Yep.
26.
32 minus 6. Oh, God, I have a headache. Bad headache.
Okay. 2 next.
A what? Yeah.
Okay. So for 2, we have to solve for x also. They've given us the top base, they've given us the bottom base, and they've given us the value of the mid-segment line.
So, we know that 2x minus 2. Yeah, 2x minus 2 plus x plus 7 divided by 2 equals 37.
Correct. Now it's easy from there.
Times 2 times 2.
You want to finish it, or do you want to... In other words, that's not going to give you any problem.
I still want to do it.
All right. So what do you get? What's the next line?
3x plus 5 equals... I'm just going to combine like terms, because I can.
Okay. Multiply everything by 2 to begin with. So you get rid of all denominators.
Yes. Oh, yeah, 74.
Okay. Now you get 3.
And then subtract 5. 3x equals 69 divided by 3, x equals 33.
23.
And then plug that in. 33 plus 7 equals 440.
It's 23.
Segment A.
It's, x is 23.
What?
X was 23.
Oh, yeah, no, you're right.
So AB is 30.
30.
Okay. The next figure is called what?
AC. So we know that this is a kite.
Okay. Because a kite has two adjacent, these two sides are equal and those two sides are equal. And it's a quadrilateral.
Yep. And then we also know that diagonal AC bisects diagonal DB.
Correct. So we know this side is also x plus 16.
Yep.
AC is 7x plus 2 dB. Where is dB? Oh, that's the horizontal line?
Yep.
Okay. So what do we got? Give me some equations.
So I'm just going to start off by combining like terms. So 2x plus 32 equals 7x plus 2. Subtract 2 from both sides. 2x
hold
plus
on.
30.
Diagonals are not equal to one another.
No, I know.
Well,
oh, yeah, you're right.
You've set the horizontal diagonal equal to the vertical diagonal.
Sorry, 66. Sorry, equals 66. I don't know what I was thinking there.
All right. And that allows you to solve for x. 2x equals 34, x equals 17. And now you can solve for AC once you've solved for x.
Yep.
So AC is 17 plus 2. 119, 121. AC.
Okay. So now we're looking at CAD.
Okay.
So
number 4.
Since it's a kite, since we know it's a kite now, we also know that diagonal AC bisects. We also know that diagonal AC bisects. Yeah, the two vertex angles.
Okay.
So yeah, so we know that CAD equals 9x.
Okay.
But
so angle CAD definitely equals 9x. How do we solve for x?
So we know that 15x minus 15 equals 90 degrees because the diagonals of a kite are perpendicular.
Correct. That a plus 15 or a minus 15?
Plus 15.
Plus?
No, sorry, it says minus 15, but I'm thinking about solving the equation. X equals 21.
Oh, I'm getting
9.
7. I'm getting 7.
What? Oh, I didn't transfer the 1 down. I just said 5x equals 105.
Okay.
Yep, that makes sense.
Okay.
Times 7.
And now you can solve.
So 9 times 7. Yeah.
So what's that angle CAD equal to?
63.
Got it. Okay. Let me see if I can blow this up just a little bit. When you're taking these pictures, try to get the left border a little bit further left.
Well, I tried to do that, but it was blurry.
Uh-huh. Okay.
Too blurry for vision.
That's okay. I can actually work with this pretty easily. I can't see all the letters, but I can kind of figure them out. So here they want to
Sometimes pictures
figure out BAC. BAC, which is angle A, is equal to which other angle that we're looking at?
it's equal to BAC is equal to BDC.
Okay, BAC.
And then we also know that ADB and CDB are supplementary.
Okay, so I know
So
2x plus 1 plus 3x plus 24 equals...
I'm going to start by combining like terms equals 180.
Okay.
I hate having to combine like terms and take up a step.
It's all right. You're actually good enough that you could probably do this in one step. I know I can. In other words, I'm immediately going to combine that, and I'm going to leave it on the left side. The 1 plus 24 is 25. I'm going to move that to the right side, which means subtracting it, giving me that.
Yeah.
Now x is 31.
That's technically 2 steps.
You're right, it is. It's just that I kind of did one of them in my head. In other words, notice that I didn't write the second step. In other words, if I'd have wanted to write every step, I would have said 5x plus 25. That's kind of what you're doing, right? You're gathering.
So then all you need to do is plug in. 2 times 31 plus 1, that would have to equal 63.
You got it.
Measure angle AC equals 63 degrees.
Okay. That's angle BAC. Okay.
And so we know that trapezoid ABCD is an isosceles trapezoid, meaning that those angles are congruent.
Okay. So what equation? Give me an equation I can write.
6x minus 11 equals 2x plus 33. Add 11 to both sides.
Okay.
X equals 2x plus 44 minus 2x. 4x equals 44. X equals 11. And then since we know that, we can subtract 6 times 11 minus 11, which would get us 55 from 180.
Right, because we know this angle is supplementary to that angle.
Minus 55 would have to equal 125 degrees.
Correct. That's angle B.
So,
and angle C.
Yeah.
Okay. To 7?
Okay. 7. So this is an octagon. Am I right?
Well, how many angles do we have? 8? Yeah.
Yeah.
So let's have the same number of angles as sides. And it's actually a lot easier to count angles. For some reason, when you count sides, it's easy to kind of get confused at where you started from. Whereas when you count angles, it's real easy. You see 8 of them immediately. What are we trying? We're trying to solve for x? Okay. So what's the measure of each of those interior angles?
What?
What's the measure of each of those interior angles? Because not only is it an octagon, it's a regular octagon.
I'm doing that right now.
Okay, what's the formula?
So n minus 2 over 1. No, never mind. Over n minus 2 times 180 over n.
Correct.
So 1080 divided by 8. That would equal...
Where are you getting 1080? Oh, that's 6 times 180. Okay.
Yeah.
Now, let me have you do that slightly differently. Notice that the way you did it involves big numbers, right? 1080. I'm going to need a calculator almost to do that. Well, let's simplify it.
Oh, I see what you're doing.
Let's divide that by 2 and that by 2. Now 4 goes into 180 45 times. I know that, so instantly I can do all of that without a calculator. The key is to simplify it first. If you just multiply numerator straight across and then divide by the denominator, you end up with big numbers. You're going to have to use a calculator most likely. But if you simplify it first, that doesn't happen.
Yeah, you're right.
All right.
So then we know that 6x plus 33 equals 135 degrees. Minus 33 minus 33. 6x equals 102 degrees. Divide both sides by 6.
17, I think, isn't it?
Yeah. X equals 18.
I think it's 17.
What?
I believe.
Oh, yeah, you're right.
Now,
17?
I didn't do it on paper. I was doing it in my head. But here's what we got. We got 6x plus 33 equals 135. 6x equals 102. X equals
17.
1 with a remainder of 42. 17.
Yep.
All right, let's look at 8. These are always kind of interesting where they have side-by-side figures. The only thing we don't know that that triangle is isosceles. Looks like it might be, but they don't tell us that it is.
It actually doesn't exactly look isosceles to me.
Okay, it doesn't matter. We don't need that. We're going to figure out what each of those angles is on that pentagon. So each of those angles on the pentagon.
Yep. 5 minus 2 times 180 over 5 equals length. So 540 divided by 5, and that would have to be 108. Yes.
Okay. That means that angle down here.
Yeah.
That's a linear.
It must be 72.
Angle. So that angle is 72.
It must be 72. Yep.
Now
and
we can figure out
108 minus 66 minus 72. So 180 minus 72. 108
X
minus 66.
What is that? 138, 42 equals X minus 4. X equals 46.
Wait, what? Yeah, you're right now. No. Wait. Give me a second.
All right. I'm really used to this subtracting.
Yeah, you're right. Yeah.
Subtracting numbers from 180 is a skill you want to have when you're doing geometry, because you're doing it every problem almost. There's very few problems you're not subtracting something from the number 180. So what I did was I added those two together to give 138, and then I know how to subtract 138 from 180 real quickly. 42.
Yep.
All right. Shall we go to the next page?
Yep.
That must be that second one, right?
Yep.
Yeah. All right. Blow it up so I can read it. Number 9. We have a regular octagon and a regular hexagon. We're supposed to find.
So I think I know how to do this.
Okay.
You divide 360 by both number of sides, and then you add those together. Because they're exterior angles, right?
Well, let's take it one step at a time. You kind of lost me in the explanation here. This angle, can you see where I'm pointing?
Yeah.
What's that angle? That's an interior angle of the octagon.
Yep. It's an exterior. Yeah.
It's an interior. So what is that angle?
What? That is an interior angle of the octagon.
I think it's 135. Didn't we just do that problem? In other words, it was 6 times 180 over 8. That's 3, 4, 45. Yeah, that's 135 degrees.
Do we need that, though?
Yeah, I'll show you why. What's the interior angle of the hexagon?
No, but I think I might have found an easier way.
Okay, tell me. What is it?
You know how the all the exterior angles of polygon must add up to 360 degrees?
That's not an exterior angle. 3x is not. However,
but
3 of those...
Technically, it's an exterior angle of both.
Well, you're making it more complicated than it needs to be. In other words, we need to find this angle right here. Once we find this angle, the interior angle of the hexagon, we'll have our answer because we'll know that all 3 angles have to add to 360.
Yep.
Okay, so rather than thinking of exterior angles, this 3x is not an exterior angle of either the octagon or the hexagon. To get an exterior angle, you got to have something like this. In other words, there's a hexagon. If I want an exterior angle, it's got to go like that. Now that is an exterior angle. But notice that doesn't happen here. The only thing we see is that the sum of those 3 angles has to equal 360. Not because of the exterior angle theorem, but because when you have 3 angles about a point, you know, if I have an angle there and an angle there and an angle there, angle 1 plus angle 2 plus angle 3 have to equal 360. You with me?
No.
No?
Yes.
Okay. So what's the interior angle of the hexagon?
So that would be 4 times 100. And no, sorry. 4 times 180, yes, which would equal 720. 720 divided by 4.
Divided by 6.
Yeah.
Always remember the denominator is going to be 2 more than that.
720 divided by 6, sorry.
Right. Again, let's simplify. Let's simplify. That goes into that 30 times. I can do that on my fingers even.
Yeah.
Whereas dividing 720 by 6, not so easy.
Yeah.
Always reduce before you proceed. You will make fewer mistakes. Especially when you can reduce so easily. In other words, 6 goes into 180 such a perfect number of times, 30, that it makes the problem so much easier if I do it this way rather than multiplying 4 times 180 and then dividing by 6.
Hey, I'm just saying, I did it my way and I got the same answer.
Oh yeah, no, you will, for sure. No argument there at all. I'm just trying to give you tips on when you do your arithmetic, doing it in a manner that minimizes mistakes.
But, yeah, you're right. But this was a special case, and to be fair, my way took less steps.
Well, I'm not sure it did. I divided top and bottom by x, that was 1 step, and then I multiplied 4 times 30, that was 2 steps. You had to multiply 4 times 7, and then you had to divide by 6. I guess yours was 2 steps also. But the problem was...
No, mine was finding the exterior angles of both the average exterior angles into the regular, and then adding them together.
So you're saying the exterior angle of that is 45, and the exterior angle of that
of the hexagon is 60.
And adding those two together gives 105, which is the answer, isn't it? Yeah, you're right. Okay, who knew? I didn't know that you could do that.
I don't know. It's just what I thought first.
Well, it's an interesting way to look at it. To me, that's much more complicated because 3x is not an exterior angle to either figure.
I know, but added together, it is.
Okay. Okay.
So 3x equals 105 divided by 3.
Right. So that's 35.
Yeah. Yeah.
Is x. Okay. Let's look at number 10. What kind of shape is number 10?
That's a parallelogram.
Correct.
And the diagonals bisect each other.
Correct.
So A equals 4x.
Hold on.
We don't even need...
Yeah.
Oh, yes.
Are the diagonals equal to one another?
No.
No, they're not. They do bisect one another, but they are not equal to one another. And the way you can kind of tell that, if you're ever wondering, make yourself a really long parallelogram like that. And now you can tell there's no way that distance is the same as that distance.
Yep.
But they do bisect one another. So what can we say? They've given us AE, they've given us EC. We know those have to be equal. That allows us to solve for x.
All we need to do is set those equal to each other, AE and EC.
Okay, let's do that. So we got 4x minus 2 equals 2x plus 16. Solve for x.
Add 2 to both sides. 2x plus 18 minus 2 minus 2x. 2x equals 18 and x equals 9.
Okay. Now they want the perimeter of A, B, C. Well,
but they give us AD and E and DC, and we know that AD is congruent to BC because it's a parallelogram, and then also DC is congruent to AB.
Okay.
So 2 times
Hold on.
6.
DC is not congruent to AD. It's congruent to AB. Okay, that's probably what you said. Yeah.
Yeah, I said DC.
Okay. So AB is the same as DC. X is 9. So AB equals 6 times 9 minus 9, right?
Yep.
So AB is 45.
Yep.
Now BC is congruent to AD. AD is 18 plus 13, 31. So BC is 31. And now the only thing left is AC. How long is AC?
We don't need a wait.
Yeah, they want the perimeter of triangle ABC, so we need AC.
Yeah, AC would have to be I think it'd be less complicated. Okay, we'll just do
It's twice this, right? Or twice this.
Yeah.
Either one.
4 times 9 minus 2 equals.
So it's 4x plus 32. It's 36 plus 32. Should be 68. Ah, that's the length of AC is 68. Did I do my math right?
Yes.
18 plus 16 is 34, and if I take twice that, I get 68. So yeah, AC is 68. And just add up those three numbers and you have the perimeter of that triangle. 76, 144.
The sum of, okay,
I think
on decagon is 11 sides. So 9 times 180. 9 times 180. 1620, right?
Yes.
Okay. The measure of each interior angle. So 6 times 180. What would be that? That'd be 1080. Yeah, 1080 divided by 8. That would be 135, right?
Yes. That's not a bad one to memorize. I mean, that's the third problem we've come across that made us figure out what the interior angle of an octagon is.
Okay. So 360 divided by...
There is a mistake. There is a mistake here.
What?
They didn't say a regular octagon.
Oh.
In other words, if you have an octagon that's not regular, then the interior angles are not all the same.
Then it can't be determined.
Ah, that's the answer. Whereas number one, you can determine the sum of the interior angles. But on number two, given the fact that they did not call it a regular octagon, it cannot be determined.
Yeah, and 3 is 40 degrees.
Okay.
And then 4 is obviously 360 degrees.
Correct. The sum of the measure of all the exterior angles of any figure, regular or not, is always 360. Yeah. Okay.
Hexagon is 10, right?
Yes.
So 1,440 divided by 10, 1,144. That was easy.
Hold on. It's not.
8 times 140, 8 times 180 equals 1,440.
Okay, I got you.
And then divided by 10 equals 144. The diagonals of every rectangle are angle bisectors. No. They are congruency.
And this one,
Angle bisector.
Yeah, this one they do call it a regular decagon. And
yeah.
They left off the word regular in number 2, so that's why it cannot be determined. But
I'm guessing that was a trick question.
Yeah, I'm guessing you're right. I think it was a trick question.
And if I get it wrong, I'm going to bring it up with Mr. Yansak.
Yes, absolutely. Please do.
And if I get it right, then that's pretty good.
Uh-huh. Yep. Absolutely.
Consecutive angles of a parallelogram are supplementary.
Did we do number 6?
Yeah, they're congruent. The angle diagonals of every rectangle.
Okay.
The diagonals of every rhombus, well, they're not, are they? Yes, they are angle bisectors.
What's the definition of a rhombus?
Yes, they are perpendicular bisectors and angle bisectors, so that's A and B, so D.
Okay, the definition of a rhombus is 4 equal sides.
Yes.
So parallelograms can be rhombuses, squares can be rhombuses, rectangles.
Well, squares are rhombuses.
Right.
Squares are rhombuses.
Right. But you could also have a parallelogram that could be a rhombus. Would also be a kite at that point also. So
a parallelogram can be a kite?
No. Well, yeah, that's a good question.
If you have 4, because that would be, you'd have to have.
Yeah, it would have to be a rhombus also. In other words,
or
I
it have to be parallelogram.
That, and I can make that equal to that. So that's the definition of a kite, right? Now, the question is a rhombus a kite? And I'm not sure if that's, in other words, I'm not sure if a kite has to have this measurement different than this measurement. I think it does.
A rhombus is not a kite.
Okay. So you're saying if I draw a pure diamond, it's not a kite.
Yeah, because kites don't have any parallel lines, and rhombuses have to.
Well, here's the question, and this is what I'm not totally sure of. That's a kite, right?
Yep. I'm going to look it up right now on my
Definition
definition.
of a kite is that side's equal to that side, and that side's equal to that side. The question is, can that side be equal to this side? In other words, if I draw a perfect diamond, well, I think I still have a kite, because that's equal to that, and that's equal to that.
Well, wait, a quadrilateral that has two pairs of consecutive congruent sides, but in which opposite sides are not congruent.
Okay. All right. So that does eliminate the diamond. Yeah.
And rhombus.
Right. Right.
Well, isn't a rhombus a diamond?
A rhombus is just 4 equal sides. So a rhombus could be a square. The definition of a rhombus is 4 equal sides. That's it.
What's a diamond then?
Well, a diamond is 4 equal sides of parallelogram, I guess. Actually, most diamonds, these are right angles. If you go on a baseball field, you're going to see that these angles are right angles. So there's my diamond.
Well, if they're right angles, then the other two would also have to be right.
Right. You're right. It would be a square. A diamond is a square. Yeah. In other words, that's equal to that, and that's equal to that, and it's a right angle, therefore it's a square.
Yeah, yeah.
All right. So let's see. Did you answer both? The diagonals of every rhombus are what?
Are A and B, perpendicular bisectors and angle bisectors.
Correct. Okay.
The vertex angles of a kite are always congruent to one another are B, non-vertex angles. The mid-segment of a trapezoid shares this relationship with the two other bases.
Hold on, let me look at 9 again. The angles of a kite that are always congruent to one another are opposite angles, I believe. No, opposite angles are
they're not. Well,
the only ones
those are called non-vertex.
Is those two.
Well, then again, these two at the top and bottom are also opposite.
Well, I'm trying to understand what they mean here. The ones that are
we just call
always congruent, the vertex angles are not congruent.
Yeah.
The non-vertex angles.
So we just call them non-vertex angles.
Okay, I got you. And that's what I put here. These are the non-vertex angles, but they're all.
And then the mid-segment of a trapezoid share this relationship with the two bases, parallel. Classify the regular polygon in which each interior angle measures 150. So to reverse that, you have to do, I see.
Just write an equation. Whenever you're not sure how to do something, write
180 over n equals 150.
Okay. Now we just have to solve for n.
N minus 2 times 180 equals 150 n. So 180 n minus 360 equals 150 n minus plus 360 plus 360 minus 150 n minus 150 n. 30 n equals 150. No, 360 divided by 30.
You got 30n equals 360, right?
Yep. Divided by 30. Don't.
N equals 12.
Won't give you that. 12. 12, yes.
Okay.
N equals 12. So it would have to be a dodecagon.
Yes.
Classify the regular polygon in which each exterior angle equals 120. So 360 divided by 120n, right?
Uh-huh. Gives you which figure?
Wait, I didn't have another math. Oh, it'd have to be a triangle.
Yeah. In other words, there can only be 3 exterior angles. That makes it a triangle.
Yeah.
Okay. Let me bring up the next.
Okay, and next page.
What's that?
I know, I'm just saying go to the next figure.
Okay.
So, I don't like some of these equations. Some of these are just tedious.
Well, I see we have a proof down here. Oh, yeah.
2 proofs, and then 1 angle puzzle.
Oh, yeah. The angle puzzles, these are going to be time consuming. We're not going to have time to do all 3 of these.
Just do the proofs.
Okay.
Because I can do the angle puzzle.
I figured you probably could do these. You just kind of have to figure out what A is. Sometimes you can figure them in order of the letters, sometimes you can't. Doesn't matter, but obviously I can figure A, and once I got A, I can figure B. Once I got B, I know this angle and I can figure C. D is the same as the linear pair to C because they've got parallel lines with the transversal. So these, you can work your way through that. I would be surprised if you can't figure out how to do all of those on your own. So let's look at the proof.
So I'm doing the given, and right now I'm in the process of stating that each angle is a right angle.
You're talking about for the proof on number 14?
Yeah.
Well, let's see. What are we trying to prove? We're trying to prove that ART is congruent to ACE. What do you suppose we're going to use for the congruency to prove?
You know what? I already know what we're doing. I already know what we're doing.
Before
we're just proving. We can do this in very few steps. Since we know that it's a rectangle, we also know that RE is parallel to TC.
Okay, that unfortunately doesn't help prove those 2 triangles.
You're right. You're right.
However, I know that there's vertical angles there. Those are equal.
Yes, and then we also know that all that the diagonals are congruent and that they bisect each other.
Which now we got side, angle, side.
Yep.
That's why I asked. In other words, if you know what you're going to use to prove they're congruent, it kind of helps with the proof. In other words, I've thought it out in my head, and I can tell that I need to prove side, angle, side.
Let me see what, yeah. And only its where does it say that rectangles, diagonals,
Bisect.
that they bisect each other?
Well, if they bisect one another, and they're equal, because it's a rectangle, then we know AT is equal to AE, and RA is equal to AC. So we have side, angle, side. That's all we need.
I know, but how do we, I don't know the proof or the postulate, or, wait, is it a definition?
Definition of rectangle. And
nope.
There is a theorem that says the diagonals of a rectangle are equal and they bisect one another.
It just, no, theorem 8.13 just says a parallelogram is a rectangle if and only if its diagonals are congruent.
Well, we don't have a parallelogram here. We have a rectangle. And a rectangle, the diagonals are equal to one another and they bisect one another. Now, I don't know what theorem number that is, but you certainly state that statement and that reason. In other words, here's the way the proof's going to be.
Wait, we can prove that. Whoa. We can prove that it's a parallelogram, though.
We don't need to. a rectangle is more specific than a parallelogram. So that's going backwards. In other words, statement one is it's a rectangle.
Yeah.
Reason given.
I'm just doing two that
Statement two is ET equals RC.
Vertical angle for congruent.
That's not yet. We'll get into that. If we're going to do side angle side, then we got to prove that AE is congruent to AT.
Yep. How?
Because diagonals of a rectangle bisect one another. That's what makes AE congruent to AT.
Okay.
So line 3 would be AT is equal to AE. Why? Because diagonals of a rectangle bisect each other.
I'm also doing that AE is equal to EC. AC. AR is congruent to AC.
You could say both of them in one statement and then just give the reason of diagonals bisect one another. And then finally, number 4 is angle RAT equals angle EAC, vertical angles. Finally, statement number 5, that rectangle's congruent to that rectangle because of the side angle side postulate.
Yep.
All right. Should we take a look at 15 real quick? It really helps when you're doing these 2-column proofs to know how you're going to do it in your head, almost in paragraph mode. And if you can figure that out first, then the rest of it kind of follows. In other words, I figured out that I'm going to prove these two are equal or congruent based on side angle side. And now I go through and how do I prove that that side's equal to that side's equal to that side, and that angle's equal to that angle. So knowing how you're going to do it helps a lot when it comes time to prove it. Okay, so this is asking us to prove that the kite's diagonals are perpendicular. They tell us it's a kite, okay, which makes EA equal to LE and it makes AS equal to LS, definition of a kite, or given. We're trying to prove that AL is perpendicular to ES. List both givens as step 1 of your proof to make the number of steps work out right. In other words, there's actually 9 steps, and they want this entire given on line 1.
Wait. Oh crap. Well, I can't use the theorems that state that the diagonals bisect each other, since that's after.
Right. Well, they don't really either. They don't bisect each other. The long diagonal bisects the short diagonal. That's it.
No, sorry. They bisect the angles, the vertex angles.
Okay.
Yeah.
So
the vertex.
Let's see if I can draw it and figure out how to prove that they're perpendicular. So you know that that angle is equal to that angle, right?
Yep.
And this angle is equal to this angle. Now, how are we going to prove that that is perpendicular?
No, because that comes after.
Didn't hear you.
Wait, what? What are you talking?
I didn't hear what you just said.
Can you please restate that?
I haven't figured out yet how we're going to prove that that's perpendicular. I have an idea. My idea, and this angle,
well, we don't know that.
we know those angles are equal. Hold on a second here. And we know this side is
well, I can't use that
side. If I can prove that triangle 1 is congruent to triangle 2, then I will prove that that is a right angle. Right?
Yep.
Okay. Well, we know these two sides are equal. We know those two angles are equal, and we know the middle side is the same as itself. So
we don't. We can't use the fact that those two angles are equal yet, because that theorem comes after, and we can't use theorem. We can only use theorems that come before.
Hold on. Well, that's not technically true. Maybe for your class it is. In other words, he doesn't want you using theorems that you haven't got to yet. You're saying you haven't studied congruent triangles? You've gotten to proving two triangles are congruent.
Yeah, but we don't know that those two angles are congruent. We can't prove that.
Let's go back. Follow what I'm doing here.
We
technically
the theorem
to that side.
Technically, one theorem says.
Okay. See this angle at the bottom that's got 3 hash marks in it? Those two angles are equal to one another. This side is equal to that side, and that side's equal to itself. So by side, angle, side, we know triangle 1 is congruent to triangle 2.
That's the thing. I can't prove that those two angles with 3 hash marks
are congruent. Diagonals bisect the vertex angles.
I know, but for this proof, I can only use theorems that come before the one we're proving.
All right. Well, it's time to go anyway, but I don't know the order that your theorems have been taught to you. So
I know, but
it's hard
I just can't
to eliminate. I think you're wrong, actually. I think you can use it. In other words, it's a kite. So by definition of a kite, you know that the diagonals bisect the angles.
Wait. A kite can also be thought of as 2 isosceles angles that share a common base. No, we know now that these, I got it now.
All right, cool. Run with it.
Okay, yep.
All right. I will talk to you next week. And I assume your brother is having his session now, right?
Yep.
I will text him the meeting ID number as soon as I log out and log back in. All right, Bolton. Bye-bye.
Okay.